Today in lesson 3.10, I want to show you how to use the standard algorithm without the place value models. Zearn has done a really good job of showing you the relationship between the place value models and the standard algorithm, but I want to make sure that you understand how the standard algorithm works without using place value models. So first we're going to look at this problem, 431 times 6. So when you are multiplying with one digit on the bottom, all you need to do is make sure that that digit has been multiplied by every single number on top. So for example, I'm going to do 6 times 1 and I'm going to get 6. And then I'm going to do 6 times 3 and I'm going to get 18. So like they showed you on Zearn, it's not all going to fit, so I'm going to put the 8 here and I'm going to carry the 1 over here. I'm adding another group. 6 times 4 gives me 24. Then I'm going to add one more and get 25. And I get 2,586. Now the reason why I can just write these numbers here is because they are still in their place values. So for example, 1 times 6, that is the ones place. This is in the ones place. This is the same as 30 times 6. And since this 8 is in the tens place, that would be the same as the 8, and the 8 being an 80, and this being this 1 carrying over to the hundreds. And then we have 4 times 6, which the 4 is in the hundreds place. 400 times 6 would be 2,400, plus another 100 would be 2,500. So it all lines up. It's just showing you and breaking it down in smaller pieces. All right, so let's go ahead and look over at this problem over here. I want you to go ahead and try this one on your own first, and then I will show you how to solve it. So with this problem, we have 348 times 5. And all I need to do is make sure that I've multiplied this 5 by every number going in place value order. So I have 5 times 8, which gives me 40. This 0 can go here, but that's not all going to fit, so I am going to carry this over to here. Then I have 5 times 4, which gives me 20, plus 4 more 10s, which gives me 24. Put my 4 here, carry my 2. Then I have 3 times 5, which gives me 15. Then I'm going to have 2 more, which gives me 17. And then I end up with 1,740. Let's go ahead and take a look at it with a 4-digit number on the top. It's the same exact thing, it's just another place value to multiply in before you're finished. So I'm going to go ahead and I'm going to multiply 3 times 2, which gives me 6. 3 times 1 in the tens place, which gives me 30, but there's already something in the ones place, so I just write 3. 3 times 2, which gives me 6. And 3 times 6, which gives me 18. And I have 18,636. The last problem that I want to have you practice is 4,309 times 4. All right, I have 4 times 9, which is going to give me 36. I'm going to put my 6 here and bring my 3 up here. 4 times 0, which gives me 0, but I still have this here, so I'm going to add this 3 here. So I end up still having 3 10s here. So 4 times 0 10s gives me 0 10s, plus 3 10s that were bundled and moved over, which means I have 3 10s in the end. 4 times 3, which gives me 12. I'm going to put the 2 here, carry my 1 over. 4 times 4, which gives me 16, plus 1 more gives me 17. 17,236. If this method without the place value just doesn't jive for you, that is totally fine. Please feel free to use the place value models that they've shown you in Zearn, but I wanted to make sure that you saw how to do the algorithm without the place value models.